Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 2nd, 2025, about 6 days ago. It delivers the first large-scale empirical snapshot of real-world AI agents, and finds that most production systems are surprisingly simple and tightly controlled, with 68% executing at most 10 steps before a human steps in, 70% just prompting off-the-shelf models, and 74% leaning mainly on human evaluation. The paper is titled, Measuring Agents in Production, and as we will see later, the implications for reliable real-world deployment are quite significant. Alright, the introduction set up the big question of whether agents actually help in practice. Figure 1 shows why teams say they deploy these systems, and the top bar highlights productivity, with about 73% citing faster task completion as a key reason. The next few bars cluster around reducing human hours, automating routine work, and boosting client satisfaction. The shortest bars show that risk mitigation and faster failure response matter, but only for a minority of practitioners. Well, Figure 2 shifts from why agents are used to where they are actually deployed. The bar chart shows that finance and banking lead by a wide margin, followed by technology and corporate services, so early agents concentrate in data-heavy, process-driven sectors. Mid-tier bars cover data analytics, research, and software development, which reflects strong uptake inside technical organizations. Smaller bars for legal, healthcare, customer support, and retail show that adoption is spreading, but remains thinner in highly regulated or consumer-facing domains. So while Figure 2 mapped the high-level sectors, Table 1 spells out concrete agent use cases inside those areas. The business operations block lists things like insurance claims, workflow automation, and human resources task assistance, which show agents as back-office productivity tools. Communication services entries describe multi-language communication automation and automotive communication services. Scientific discovery rows focus on biomedical workflows and regulatory analysis, so agents help scientists navigate complex data and rules. The software operations sections cover data analysis, cloud engineering help, incident response, and developer support, highlighting deep adoption in engineering teams. Alright, Figure 5 turns from use cases to how these systems interact with users in practice. The left panel shows that over 90% of agents primarily serve human users, with internal employees slightly ahead of external customers, while non-agentic software and other agents barely register. The right panel reports latency tolerance, and most deployments accept responses in seconds to minutes, with minutes alone accounting for over 40%. Only a small share demands sub-second speed, which reflects that beating human turnaround matters more than instant replies. So while Figure 5 focused on who agents serve and how fast they must respond, Figure 6 explains what kinds of models power those agents. The left bar shows that only 3 of 20 case studies use open-source models, while 17 rely on closed or undisclosed ones. The right bar shows that just 6 systems apply post-training, such as fine-tuning or reinforcement learning, compared with 14 that do not. Overall, teams mostly use off-the-shelf closed models with minimal extra training. Alright. Figure 8 digs into how these agents are actually wired. The left panel shows that most deployments stick to a single model, with only a small minority combining 3 or more. The middle panel shows prompt length, where about half use short instructions, but a long tail stretches past 10,000 tokens for complex setups. The right panel reports autonomy, and nearly 70% cap agents at 10 steps or fewer before human intervention. Well, Figure 21 turns from architectures to what actually makes these systems hard to run. The left panel shows that core technical focus, meaning robustness, latency, and general performance, is the top-ranked challenge for almost 40% of teams. Data and model integrity and system integration and validation tie for a distant second. The right heat map reveals that transparency, governance, and compliance tend to be rated mid to low difficulty, so everyday reliability problems dominate attention far more than policy issues. So, the big message is that real production agents are narrow, heavily supervised tools, yet even these simple, bounded systems already deliver strong productivity gains. The broader implication is clear. Progress now depends less on wilder autonomy and more on rigorous evaluation, reliability, and human-centered workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.